Welcome to this explainer. Today, we're diving into Chapter 6 of our source material. But, we aren't just going to stare at a static list of math problems. No way. Instead, we're going to transform this chapter into a totally dynamic, basically a leveling up toolkit for multiplication strategies. Think of it like a journey. We're going from absolute basic facts all the way to mastering those really complex, multi-digit calculations.
So I want you to hold on to this idea for just a second. Imagine looking at those massive, super intimidating math problems. The kind that usually make you just instantly reach for your phone or a calculator. Well, what if solving them just required a few really clever mental shortcuts? Because that's exactly what this chapter equips us to do. We are literally going to build up those mental math muscles today.
All right, here's our game plan for this explainer. 1. Patterns in tens and 100s. 2. Doubling and halving. 3. Breaking down methods. 4. Real-world problems. And finally, number 5, complex algorithms.
Okay, kicking things off with Section 1, patterns in tens and 100s. This is the foundation of place value.
Let's just dive right into our very first tool. So a lot of the time, we're taught to just add a 0 when multiplying by 10, right? But the text actually pushes for a much deeper understanding here. When you multiply by 10, the number literally becomes 10 times larger. That means each individual digit is moving exactly one place value to the left on a place value table. And multiplying by 100, well, that makes the number 100 times larger, so you're shifting each digit 2 place values to the left. We aren't just magically dropping zeros at the end of a number, we're actively shifting its actual weight and value. It's a total game changer when you think about it like that. Moving right along to Section 2, doubling and halving strategies. I like to call this the mental math cheat code. Let's see how this actually builds our mental agility. Seriously, this is a brilliant shortcut, and it works especially well with numbers like 5, 25, or 50. The core concept here is wonderfully simple. If you take a multiplication problem, cut one of the numbers exactly in half, and then double the other number, the final product stays exactly the same. You're essentially just balancing the equation on the fly to make the numbers way friendlier for your brain to process. To put that into perspective, take 18 times 5. Now, for a lot of people, that definitely requires pausing and doing a bit of mental heavy lifting. But what if we cut 18 in half? We get 9. And if we double 5, we get 10. So suddenly the equation becomes 9 times 10. Which of these makes more sense to your brain? 9 times 10 is instantly 90. By just halving and doubling, we totally bypassed the hard math. And we just relied on that base 10 foundation we literally just talked about. So cool, right? All right, Section 3, breaking down multiplication methods. We are deconstructing big numbers here. So the really crucial point to take away here is that multiplication is incredibly flexible. Let's look at how the chapter tackles two-digit multiplication. The text actually presents us with two totally different approaches from characters named John and Conti, and they're both trying to solve 35 times 12. So John deconstructs the problem entirely. He breaks 35 into 30 plus 5 and 12 into 10 plus 2. Then he multiplies literally every single piece together across 4 distinct steps. 2 times 5, 2 times 30, 10 times 5, and 10 times 30, and he gets 420. It's highly detailed. Now Conti, on the other hand, she's a bit more efficient. She keeps the 35 completely whole and just breaks the 12 into 10 plus 2. She multiplies 2 times 35 to get 70 and 10 times 35 to get 350. Add those together and yep, she also gets 420. Both methods are absolutely correct, and what's really important is that both methods still rely heavily on manipulating those tens and hundreds to actually find the answer. Okay, on to Section 4, solving real-world problems. This is where we're taking the math right off the page.
Let's just step away from pure numbers for a quick second and actually apply our new toolkit to real life. Imagine you're in a movie theater auditorium. It's got 8 rows of seats, and each row has 12 seats. Now, if the theater were completely full, we'd multiply 8 by 12 to get 96 seats. But the problem here asks, if only half the seats are filled, how many people are actually watching the movie? Well, we could find half of 96, which is 48. Or, using our new toolkit, we could just say, hey, half the rows are filled, so 4 rows times 12 seats equals 48. See what happened there? Suddenly, word problems are just these fun little puzzles practically begging for our shortcuts. We also see characters throughout the chapter applying these exact same tools to their real jobs and everyday lives. For example, Daljeet runs a milk processing unit, and she uses arrays and groupings to super quickly calculate large numbers of butter packets. And then there's Nita. Her family produces 35 kilograms of kitchen waste in a single month. To figure out the annual waste, she has to multiply 35 by 12 months. Notice anything familiar? That is the exact same math problem John and Conti were solving just a minute ago. These math strategies absolutely serve practical, everyday, real-world needs.
And here we are, Section 5, Mastering Complex Algorithms, specifically Millie's father's method.
All right, we have officially arrived at the boss level of Chapter 6. This is where we bring the whole shebang together, multiplying a 3-digit number by a 2-digit number. Let's just walk through this nice and slow, using this example from a dairy cooperative that's tracking milk from Gur cows. The problem they have is 453 times 13. Okay, step 1. We multiply the entire top number, 453, by the ones digit of the bottom number, which is 3. So 453 times 3 gives us 1,359. Step 2. We multiply that top number by the tens digit. But wait, remember our very first lesson? It's not just a 1, it is a 10. So we're actually multiplying 453 by 10, utilizing that exact place value shift we learned to get 4,530. And finally, step 3, we simply add those two partial products together, and boom, we get the final answer, 5,889 liters of milk.
Now, what is really absolutely crucial to understand right here, and the text explicitly points this out, is that even when we are carrying numbers in this super complex algorithm, we're still just manipulating those place values. When you multiply and carry a digit over to the next column, you aren't just moving some random number. Just like the quote from the text highlights about a slightly different problem, it says 30 is added to 4 times 60, 200 is added to 4 times 200. Everything stays completely anchored in tens and hundreds. It's the exact same fundamental logic we started with today, it's just layered into a really highly efficient compact format.
To wrap up this explainer, I actually want to leave you with this pretty provocative puzzle taken straight from the end of Chapter 6. It really tests if you truly grasp the flexibility of multiplication. Okay, here it is. If you know for a fact that 67 times 67 equals 4,489, how do you find 67 times 68 without actually doing the long multiplication process? Think about what multiplication really actually represents. It's just adding groups. So if you already have 67 groups of 67 and you need 68 groups of 67, what do you need to do? I'm going to let you test out your newly evolved toolkit to find the answer. Thanks so much for joining me on this explainer, and hey, keep looking for those patterns.